day. It was great.
Oh, wow, that's really cool.
My favorite.
It's really interesting.
Yeah.
What's
Jaden,
your favorite part?
My favorite part? Oh, I just always love watching about Isaac Newton and how like someone came to him and they were like, "Oh my gosh, we think there's this thing like this force," and he was like, "Gravity? Yeah, I saw that a while ago. I have the notes in my drawer."
That's really cool.
Yeah.
Before we started the broadcast, Jaden was telling me how he'd memorized pi to the 1,000th unit.
Wow, Jaden. I guess whenever we're back off air, we can ask you so that we don't waste time right now.
Yeah, because it'd take a long time.
Understandable.
Should we just get into the swing of things then, real quick?
Yeah, I'm just opening mine here.
Okay, let's see. Week 6. I was like, what week are we in again?
It's kind of crazy. It's already week 6.
I know.
Hey, you guys got grades back for your first test already, right?
Yeah.
I didn't check.
Oh, you didn't? I still haven't gotten them back yet. I got like
She just trusted that she got a good grade.
No,
that's how much she's worried.
She was just using faith that she would get a good grade, so she didn't have to check.
I just didn't see it pop up in my notifications, so.
Excuses.
I know, chat.
Okay, I got my page open up here.
Perfect. Did everyone get all of the exponent rules?
I think so.
Are you talking about exam 1 or exam 2A written portion?
Exam 1 written portion.
Oh yeah, I got that back a long time ago.
Nice. I got a 0, and then she's like, "Oh, for some reason it didn't come through when you turned it in." So she had me resubmit it, but she still hasn't graded it yet. So that's okay though.
She said, "Good work, Susan." Sister Blackhand.
Good work, Susan. You're my favorite student and the most smartest out of all the other students.
The most smartest.
Most smartest, most important person in the entire class.
Not true. Okay. Problems.
Sorry, what was that?
Extension problems thing we're doing.
You know math. Yeah, that.
Sorry. Yeah, that stuff, right? Okay.
That stuff that we're really smart at.
So we've got log quantity x minus 3 equals 4.
Yep. So how would you go about this, Connor?
I believe I would just normally I'd take the base of the log and put it to the 4th power and set that equal to x minus 3, right?
I think that would be a pretty good idea.
Yeah.
How would you guys do
I would have to concur on that.
Okay.
Man, there's a lot of extension problems today.
So the base is 10.
Right. So it'd be 10 to the 4th equals x minus 3? Huh?
Yes.
I think.
Which means it's just going to be 10,003.
Yeah, 10,003. Wow, there really are a lot of extension problems. Holy cow.
Yeah. I actually had to scroll this week.
Well, it's because it's really easy.
Oh, it's really easy. I'm so smart.
Let's do the next one.
Okay.
Log base 2 of x times log base 2 of x plus 2.
Wait, did you go down or did you go to the right?
Sideways, yeah.
Okay.
Base 2 of 6 x plus 1. good news, they all have the same base.
Nice. That makes it easy. So do we want to? We can simplify the left side, right? Just put log base 2 of x times x plus 2.
I'm pretty sure that is correct.
And then we could subtract the right side over to the left side, and then using the quotient rule, make that divided by, or I guess that's not what we want. Or no, then we could do the logarithm thing, like we did on the first problem. I think.
You mean put it into exponential form, is that what you're saying?
Yeah, that.
Logarithm thing? Okay. So we have log x squared of x squared plus 2x, right?
Mm-hmm.
Equals log base 2 of x plus 1. And do you want to put it in exponential form? Did you already do that?
No, yeah, I think so. At this point, will we subtract the right side over to the left side, and then put that into like simplify that to like the division, and then do it?
Yeah, I think that would be better to get it all into one first.
Yeah, okay. Let's try that then. So we should get just log base 2 of x squared plus 2x over 6x plus 1, right?
Yeah. Equals 0.
Equals 0. Yeah.
And then we just do 2 to the 0th, which is 1.
Mm-hmm.
So 1 equals 4x squared plus 2x over 6x plus 1. And then we're just solving for x.
So we should end up with 6x plus 1 on the left, 6x plus 1 equals x squared plus 2x, right?
Yes.
And then just solve for x.
So it's just x, you just gotta put it all on one side and it's a quadratic.
Okay, nice.
So I got x squared plus 4x plus 1 equals 0.
Let's see.
Oh wait, I forgot the other one. Oh no, I multiplied. Okay, we're good. We're good.
I'm getting a minus 4x though. What did I do? What am I missing?
Okay, so I had at the beginning I had 6x plus 1 on the bottom.
Mm-hmm.
So I multiplied. And so it's 6x plus 1 on the left side. And then you're subtracting 2x from that. So instead of a negative 4x, it's just a 4x.
Oh, you subtract the 2x to that side. Okay, makes sense.
Yeah. Did you get a negative 1 then?
Yeah, I didn't want a negative from the x squared, so I just did it to the other side.
Actually, that's a really good idea. Okay. Not actually, sorry, that makes sense. X squared minus x. Okay. So then it's just a simple quadratic. And see if there's anything else.
I think I definitely overcomplicated it.
Oh no, what were you trying to do?
Again, I left them in parentheses when I moved it to the other side, and so I foiled.
Oh no.
And so now I have a 6x to the third.
Well, I mean that might work too.
It might. I mean, I could take out an x out of all the factors, and Susan's giving me the nod of disapproval.
Okay, so no, that wouldn't work because if you subtracted it in parentheses, you would just distribute the negative.
Well, I also forgot the negative.
Yeah, and then it would be an addition problem.
Yeah.
Yeah. Okay. So, but you're on the same page now, Jaden?
Yeah.
Okay.
I did a good job foiling it, though.
Proud of you.
I just want you guys to know that I did foil correctly.
I think.
Oh, goodness.
No, I guess it wasn't the right situation to foil, but I did it.
Okay. So, let's just do quadratic formula for this because I don't see an easy way to factor it.
Yeah, I didn't even try. Did you get it to the quadratic equation? Did you get to the quadratic equation, Jaden?
Not yet.
No
Let me
worries.
get there.
No rush.
So x squared minus 4x minus 1.
X squared minus. Yep, that's what I got.
Okay. That was much easier. Why'd I do the foiling?
We don't know. Okay. I got an answer.
I guess just insanity set in.
Yeah. What did you get for an answer, Susan?
2 plus or minus the square root of 5.
Cool. That's what I got as well.
Awesome.
We'll just wait for Jaden get there too.
But because the domain is restrictive, there's no plus or minus.
Let me see. Oh, yeah, you're right. So it says no plus or minus because of domain restrictions.
I don't know why that is. Okay, why would there be a domain restriction? Is it because when we combined all of the logs, there was a division, so then there would be a domain restriction. So let's see. I guess we could plug in the answer that we got, and then it should only be the positive one. Because if it's 6 times a negative number, I don't know.
I'm not following.
I actually have no clue. Okay.
Okay, so the answer they're looking for is a decimal.
No, okay, so that's what 2 plus the square root of 5 is. Yeah, so they're not looking for a decimal exactly. That's just what it is simplified. Or not really, but solved, I guess.
I'm just confused on how they got a decimal from the square root of 5.
Okay, so 2 plus the square root of 5.
Yeah.
Can you type that in?
I get 4.236, 4.24, yeah.
Yeah, so it's just a simplified decimal. I'm just confused about the domain restrictions.
Yeah, me too. I haven't finished the homework for this one, and I don't remember learning about that yet.
So I guess we can try to figure that out and maybe talk about it on Thursday.
Yeah, sounds good. Oh yeah, and then for Thursday we just have exam 2B preparation.
Yeah. So that's exciting. All right, let's work on number 3 then. Or not really number 3, but block 3.
Yeah.
Okay.
Log x minus log x minus 2. 1 minus 1 equals 2. Some of my biggest errors just come from writing stuff down wrong, so that's exciting.
That's agreeable.
Okay,
For this one, we're just gonna do the quotient rule and put log of x over x minus 1 equals 2.
log of x over x minus 1. Is that what you're saying?
Yeah.
Okay. I thought you were saying log of x over x minus 1, and I was like, wait, what are you doing?
Oh, sorry. Maybe I did misspeak.
Equals 2, and then, so that's log base 10 to, and then squared, so 100 is equal to x over x minus 1, multiply both sides, so 100 x minus 100 equals x. Subtract x there, that's going to be 99x, right?
Yeah, that's what I've got.
I'm just gonna wait. So I'm gonna just add 100 to the other side.
Yeah, that looks like a good idea.
Divide by 99. So 100 over 99. And that's the answer. Woo!
Nice.
Woo.
You did that too, Jaden?
Decimals, so
Yeah.
Okay,
I guess
cool.
we can do that.
I was about to start doing the quadratic formula for that, and I was like, wait. Then that was right when you said, I'm just gonna add it back over, and that makes so much more sense.
Yeah, you couldn't have done the quadratic formula because there wasn't an x squared.
Couldn't you just?
Come on, you should have foiled it.
Yeah, I should. Why didn't I see that coming? My bad.
I don't know.
Pretty basic.
Yeah.
Okay, so 2 ln x equals ln x plus 3 plus ln x minus 1. Okay, let's just combine everything real quick.
Mhm.
ln of x to x squared equals ln. And this time we do get to FOIL. Woohoo!
Oh, really? Do we? Are you sure?
This one.
Are you sure?
Mhm.
Ow.
Ow? What?
Yeah, like, why do we get a foil on this one and not the last one?
Because this one, when we combine, you see we've got the natural log of x plus 3 plus natural log of x minus 1, and the product rule allows us to make that multiply. It's like you put them together as multiplication.
Okay.
And then you end up
Those
having,
ones are the ones that do it.
Yeah.
Okay. So e to the 0th equals 1 equals x squared plus 2x minus 3 over x squared. Is that what you got?
Okay, wait, I got everything you said. So I got everything you said except what'd you say for the e to the what?
E to the 0th?
E to the 0th. Oh, and then you've got e to the 0th equals natural log of x squared plus 2x minus 3 over 2 or over x? Wait,
No.
over. Okay,
Okay,
say what you said again.
okay, so I went through a couple of steps. So I FOILed, and then I had on the other side natural log of x squared. And then I just went ahead and subtracted that and combined it. So 0 equals the natural log of x squared plus 2x minus 3 over x squared. And then I put it in exponential form. And so since it's the natural log, then it's going to be e, and then it equals 0 for 0th, which changes to 1 because anything to the 0th power is 1. And
Okay.
then
How'd
it
you get what? Sorry, go ahead.
How did I get what?
It's like because on the left side right now I have 2 natural log of x. How'd you get x squared?
Because when a two when a whole number or any number I guess is before the log,
Oh,
it's actually the exponent of the thing in the base, not the
so
base of the what do you call it inside of the log
the number, whatever the variable.
of the number inside the log.
So you just use the power rule to pull it back up there.
Yeah,
Okay. Is that like the only way? Is that like the way you have to do it, or is there? Because like, could you do it? Could I just like if I wanted to, could I just subtract the whole 2 natural log of x over to the other side and put them together like we did before with logs?
you could subtract it, but at some point you have to put the 2 back as an exponent.
Okay. Okay. Cool.
That's how
Okay.
that's just a rule for condensing logs.
So then you should have natural log, or it would be just x squared, not natural log of x squared.
No, it is the natural log of x squared. So I
Okay.
subtracted it, and then I used the quotient rule, and I guess, and then made it into. I put it under. I'll just show you. Okay.
So okay, yeah, okay, I follow you. Thank you.
Yeah. You got everything, Jaden?
So you don't put it in the quadratic?
What?
I put it in the quadratic.
That's what I was trying to do too.
Like, I left the other side alone for the time being, but I put the rest in the quadratic.
No, you combine everything. You have to condense the entire log.
Okay.
Okay.
I was happy because I had an actual, like, perfect square in the quadratic. I was like, I'm actually gonna be able to get rid of the square root. But no.
Okay. Is everyone to the same point now?
I'm at where you're at. 0 equals natural log of everything.
Are you there, Jaden?
Yeah, I'm just writing it down.
Okay. So now we're going to multiply to get the x squared on top.
What are you multiplying by?
X squared.
So you're just multiplying the top and bottom by x squared?
I'm multiplying both sides by x squared.
Oh, okay, so it just becomes, it'll still be 0, but equals natural log x squared plus 3x minus 3.
There are no more natural logs.
Oh, because you use the e, right, okay.
So but since it was e to the 0th power, it's 1. So
Right.
it's x squared times 1, which is just.
Right.
Why didn't we just subtract the x squared?
You mean when it was on the bottom?
No, like when it was on the other side.
We did just now.
Wait, then why is it division? Like in a fraction.
Okay, when it was still a natural log, we subtracted the natural log of x squared. And with log rules, if it's one log minus another, then you take what's inside of the parentheses and you put one on top of another.
Okay. Yeah, the other day yesterday when I started doing the homework, the videos for the rules of logs was not working.
Oh.
Yeah,
So,
I mostly just have these still in my brain from when I learned it before. But you can also just like look up like log rules or exponent rules.
Yeah, YouTube wasn't working for me yesterday either.
oh,
Oh,
bummer.
well, that always stinks then.
Yeah. It was a bad day for math. My computer was just like, you know what? You're not doing math today.
Yeah, I didn't do math yesterday either, so it's all good.
Okay, so now we've got, then we can what, just subtract the x squared back over?
Oh, sorry, I'm probably a step ahead. Yeah, so you subtract the x squared now, and it's just going to be 2x minus 3. Then it's just 3 halves equals x.
Wait, but didn't we multiply the top by the x squared?
Okay, here's the deal with fractions. If you multiply, okay, you have the numerator and the denominator. If you multiply by the denominator, it just cancels out the denominator. It doesn't apply to the numerator.
Okay. Because I started distributing the the x squared.
Stop distributing and foiling. Come on.
Don't forget about quadraticing. I did that too.
Yeah, and quadratic king. Get the answer, everyone?
I got 3 halves.
Did you get 3 halves, Jaden?
Not yet.
Take
I
your
gotta
time.
figure out where I went wrong now. Yeah, I'd get 3 halves.
You did?
Yeah.
Okay. Perfecto. Let's check the answer. Woohoo! That's right. Okay. And then we have 1.0 minus 4x minus 1 equals 5. So log base 1.02 times, or to the 5th, to the 5, or whatever you call it, equals, I'm very helpful today, x minus 1.
4x minus 1.
You are very helpful today.
Thank you.
So you said it was 1.02 to the 5th equals negative 4x minus 1, correct?
Yes.
Cool.
Okay, so I guess then we can just solve for x.
Yeah, that's what I'm doing.
So add 1 and divide by negative 4.
Yeah.
So log 1.02 to the 5th in parentheses minus, or I guess plus 1 over negative 4. And then we just have to simplify that.
Yeah, I got a decimal, a negative decimal.
It should be a positive decimal. I don't know why I have a negative 4 because I added. What am I doing wrong? Okay.
Maybe I'm doing something wrong.
No, it's not you. Okay, so
Oh, but that's, yeah, I still got a different one.
okay, so what it should be divided by negative 4, shouldn't it?
Yeah, her answer is.
But hers is positive.
She
And
also
I'm
has
not sure if I'm doing something wrong or if it should be plus 1. That part's right. But I thought it would be a negative 4.
Why should it be a plus 1?
Because, okay, so we have our log equals negative 4x minus 1, and then we're
Uh-huh.
adding 1 to the other side.
Oh, yeah, okay, that makes sense.
But then when you divide, you don't change the sign. So I don't know why the sign is changed, and I don't know if I'm doing something wrong or if it's a typo. Because she has typos sometimes, so that's
Yeah.
confusing.
Okay, yeah, I'm not sure about that one.
I think it's supposed to be negative. So
Me.
let's just plug that all in.
Okay, yeah, I got it.
What do you have? You
20
plugged it.
point.
Is that what you're saying?
Huh?
You plugged it in?
Yeah.
And what did you get? So I can see if I got the same thing.
20.568.
Did you do negative 4 or positive 4?
I did the positive 4, but it shouldn't. If I do it with the negative 4, it should just give me same answer.
Negative
It's negative.
20.568. Yeah.
Yeah.
Yeah, that's what I got. What's the positive one?
If you
Positive.
if you use a positive 4 on the bottom, which she has, then it's gonna be positive. But if you use a negative 1, like I think it's supposed to be, then it's negative 20.57.
Cool. Okay.
Cool beans. Okay.
Oh man.
Wow, we're applying it.
The
Yeah.
next ones are easy.
What?
I mean, I said the next ones are easy. I mean, mainly because I have a spreadsheet that calculates it, but
What's the formula for compounded quarterly and compounded continuously? I don't have it written down.
What's the formula?
Yeah.
It is, I have it right here. It's like A equals P parentheses. Let me grab it real quick. Okay, so it is. Okay, A equals P parentheses 1 plus R over N parentheses, all that to the NT. So it should look like a, let's see, like that. See that one right there?
Okay. A equals P. And is this for quarterly or continuously?
This is for, so I think the only difference is what you plug into the N.
No, there are different equations for continuously and quarterly.
Oh, I think it's this one then. That's the other one.
To the negative NT?
Yeah, instead of it's P equals A. I'm not sure which one is continuous, which one is quarterly, but I'm gonna look it up real quick.
Yeah, so A equals P 1 plus R over N to the NT, and then compounded continuously. Oh, it's PERT. A equals P e to the RT. I remember that now.
That's for the continuously or quarterly?
Continuously.
Continuously, okay.
So the first one, 5,000 is invested at 5.6 compounded quarterly. Quarterly, how much after 10 years?
Okay, so we should have A equals 5,000
Yeah.
times
1 plus plus R is the annual rate of interest, so
0.056.
0.056, yeah, over number of times it's compounded per year, so 4 to the 4 times 10, so 40.
Okay, yeah.
Then you just plug it in, I guess. I still haven't found my pretty calculator, so I'm still using one on the computer. So A equals 8,719.43.
So when I plug that into my calculator, I get numbers that are different. How do you? I did what's inside the parentheses, took that to the 40th power, and then multiplied it by 5,000.
What'd you get, Susan?
5,000? You should have
Huh?
multiplied by 5,000.
Multiply by 5,000?
Uh-huh.
Susan,
Yeah.
what'd you get?
I got 8,719 and 43 cents.
Yeah, that's right. That's what I got.
So what am I doing wrong? Like, so the order that I did it was I simplified inside the parentheses, took that number to the 40th power, and then multiplied by 5,000. Is that backwards?
Can you plug it all into your calculator at once? Is that possible?
I shall try.
Because it's probably just an order of operations thing that went wrong.
Hmm. 5,000 plus 11 times 1. Oops, I forgot something. There we go. Okay, got it.
Sweet. All right, now let's do the PERT equation. 5,000 e to the 40th. Okay, that didn't look very nice. Wait, it's the RT, not the NT. So I messed up.
So it should be A equals PERT. Okay.
Yeah, so it's 0.56 times 10. Right? Wait.
0.056.
Wait. 0.056.
Connor, you sound kind of violent with that calculator.
Do I?
It sounds like you're just like, bam, 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 bam.
Really? Maybe just, how about, wait. 8, 7, 5.
Okay, I got it.
How about now? Does it still sound violent?
I mean, not as violent.
Okay.
It was definitely more violent a minute ago.
Okay.
Yeah, I got 8753.36.
Yep, me too. Perfect. Next.
What'd you get?
8,756.
Wait, 8,756?
3.
Okay, 53. Yeah, I was like, okay, you're off by like $3.
I was reading it and I still said it wrong. Invest 400 into an account that has an interest rate of $2 and compounds quarterly. How long would it take for you to have $4,000? So we're gonna do 4,000.
Takes about 115 years.
Yeah, but I wanna do. Yeah, I can look at the answer sheet. I need to do the problem though. Okay, 1 plus 0.02 enter 4 to the 4 times x.
I mean, I didn't find the answer by looking at the answers. I used my sheet and it found it for me.
Yeah, but I think plugging it into a computerized equation is against the rules on the test. So
I don't know. I wrote the equation. So
yeah, it's not. I don't think you're allowed to just use an Excel spreadsheet though.
yeah. My last class my last math class, they actually had us write Excel sheets for our math.
Nice.
That's
Because if you think about it,
in
we're
the
using math in the
yeah.
real world. We're going to have these tools.
But
So,
being math in the math world,
I don't see how there's a difference.
there's a difference.
Because, I mean, how can you be doing math not in the real world?
Yeah, I don't know. I think it just depends on the class, whatever the teacher
Yeah, I
says.
need to ask her.
Yeah, because you just need to know the mathematic principles behind the math.
Well, yeah, and that's how I wrote the Excel sheets. So
which equation are we using for this one? I assumed it's just the regular, not the PERT one, but the other one.
Yeah, the compounded quarterly one.
That's one we use. Okay. So our rate's going to be 0.02, right?
0.02. Yeah.
And then that's okay. Then it's 4 times t. Okay, so then we're just solving for t.
Yes, it's just a logarithm.
Oh, so you're just gonna use the log? Okay, that makes sense.
Yeah. And x equals 115.42. Weird. Okay. Assume cost of loaf of bread is $6. 10 years compounding, find the time it would take for the cost to triple at an inflation rate of 5 years. This one's exactly the same thing. So 6 times you just for the A you do 6 times 3. So 18 equals 6 times 0.1 plus 0.05 over. Oh wait, no, it's E. So 18 equals 6e times 0.05 times t. So 18 divided by 6. natural log.
I'm not getting. I know you moved on to the other one already, but I couldn't get 115.42.
Did you just okay? Did you divide the entire thing by 4 within parentheses?
So this here, this is what I did. Maybe you can you see that?
Okay, 4 t log 4. What? Okay. Yeah, so here's the problem. You did not divide by 400 at the start.
Oh, I need to divide by 400 at the start.
Yeah.
Okay, cool, sweet. I'll come back and fix that later.
Okay. Which is the same thing you do with this next problem. You have to divide by 6 at the beginning.
Okay, cool. You guys want to skip ahead? Oh, geez, there's still so much. You guys want to skip ahead to one of the next problems?
Sure.
Yeah. Because you have to go soon, Connor, don't you?
I leave in. I have to go in like 6 minutes. I
Oh,
mean,
right.
if you guys want to keep doing it though afterwards, that's totally fine.
I've actually got a work meeting at 10 as well.
Oh,
Okay.
okay. It told me at the beginning. Okay. Discuss the different methods you could use to solve the following equation. There are at least 4 different ways to solve it. No matter which method you choose, you have to solve using log 5, log 10, natural log. What benefits you see for each of the following cases? The following guided practice. Okay.
Should just be
So
able to
the nice
get.
thing about applying a log base 3 is when you have log base 3 of 3, then that's just going to equal 1. Right? Because it's. No. Is that a log rule?
Which one? Would you say it again?
Log base 3 of 3. That means something.
Oh, so like if you put, since that's the base, we could put log. We could take log base 3 on both sides. Is that what you're saying?
Yeah.
I think I probably 2x. So in that
Okay.
case, go ahead.
Yeah. When you have log base 3 of 3 or log base x of x, then the x's and the log cancel each other out and you just have the exponent left.
Yeah.
Okay.
And then that's going to equal x log base 3 of 5. Okay. So remember that you're solving for, and thus x values need to be on the same side of the equation. So you subtract. There you go. And then we could have put log base 5, and that would have gotten rid of the other side. And then log base 10 on both sides, then you just have something in common with both sides. And then the natural log is the same thing. See. So when you have the natural log, then you're able to find everything in terms of the natural log and solve for x pretty easily. So that's the benefit of doing that, I guess. Okay, number 4. Does everyone understand anything that I just said?
Kind of.
Yeah. I was just working on the problem here while you were working on it. I got the right answer. I think I got it.
Oh, okay, good deal. Review the resources on Euler and about half-life problems. Remember that half-life is time it takes for it to decrease to 1/2 of its original amount. Answer the following question in regards to half-life.
Yeah.
Oh.
So, what is the equation? So there's several half-lives equations. Which one do we use for this one? Is it just the basic half-life equals 2 natural log over k?
I think so. Just like k equals ln of 1/2 over the amount of years.
K equals ln of 1/2 over the amount of years. Okay.
I think. And then k is going to be 0.1.
Oh yeah, okay. Wait.
Right? Because that's how low you want it to get.
Oh yeah, so we're solving for time. Okay. 0.1 equals 1 over t. So it'd be what? Natural log of 0.5.
Wait, where do we get the 3.4 grams?
So that's the initial. I want to take 3.4 grams to be reduced to that. So I don't think we actually need to put in the 3.4 grams or the 0.1 grams anywhere. I think that's just additional information. I think we have everything we need. We just need the.
I don't think.
Go ahead.
1 second. So A. Let me look at this.
Wait, let's see. So can we solve for k first and then plug that into another equation?
1 second.
Okay.
Okay, so final equals initial times 1/2 to the time over half-life. Right?
Final equal. Sorry, can you say that again?
So final amount equals initial amount times the 1/2 to the time over half-life.
Sounds right.
So we're going to do final amount, which is 0.1. Get my pencil here. 0.1 equals 3.4, right? If I remember it.
3.4, yeah.
3.4 times 1/2 to the time is the one we don't know.
Yeah.
And then what does half-life mean in this? Would the half-life just be 3.4 divided by 2?
Maybe.
Or would it be the amount of time it takes to get to the half-life?
Well, the amount of time it takes to get to the half-life is told to you in the question. That's the 5,730 years.
So what I don't know is it the half-life in regards to time or the half-life in regards to how much of the compound is actually left?
Well, wouldn't at that half-life it would be half of what 3.4 is?
Yeah, that's what I'm asking.
I think that's right. And then the half-life of that amount would still be the 5730. I think. And so you just repeat that until you reach the 0.1?
So it's the formula is T over K, right? Or T times K? It's T times K. So K equals ln of 1/2 over 5,730. And then to solve this, we would just divide by 3.4. And then we would do, let's just do the ln. No, that's not. Okay. Log base 1.1 over, no, base 1/2 of 0.1 over 3.4 equals T divided by the natural log.
All right. Sorry, guys. I got to take off.
Okay.
All right.
I'm going to plug this in and see if it worked. And then I'll text you guys and tell you if it did.
Okay.
Okay. Sounds good.
Yeah.
Good job, guys. See you later.
All right. Bye.